Imagine looking far into space and seeing a cosmic dance. Two galaxies seem to be interacting in a captivating, eerie way, nearly staring back at you. The Hubble Space Telescope and the James Webb Space Telescope have photographed this amazing phenomena in stunning detail, providing humanity with a stunning glimpse of two spiral galaxies, NGC 2207 and IC 2163. Astronomers have referred to this amazing scene as having a bloodshot eye impression because of its swirling arms and vivid hues, which show intense interactions. However, what makes this cosmic meeting so significant? The science underlying these pictures, what they tell us about galaxy interactions, and the ramifications for our comprehension of the cosmos will all be covered in this article. The first interaction of the galactic grays. What astronomers refer to as a galactic grays, a close encounter between two galaxies that develops over millions of years, is just getting started for IC 2163 and NGC 2207. Even though they haven't yet merged, they are close enough to pull at each other's stars, gas, and dust with strong gravitational forces, producing striking tidal effects. Because of its larger companion, NGC 2207, the smaller galaxy, IC 2163, has developed a distinctive ocular shape that resembles an eye. The spiral arms of IC 2163 are distorted in a taffy-like fashion by this gravitational pressure, which also stretches the disk into an elongated oval shape. The eyelid formations that develop along the margins of galaxies are actually shock fronts, which are formed when material moves quickly under these powerful forces. NGC 2207 is likewise impacted in the meantime. The arms of IC 2163 have started to lengthen due to its proximity, forming tidal tails, which are streams of gas and stars that float into space like cosmic ripples. In addition to changing how both galaxies appear, this dance of gravitational interactions gives scientists information about the early phases of galactic mergers. Scientists can forecast how similar encounters will develop by watching galaxies as they brush against one another. In billions of years, the Andromeda Galaxy is predicted to join with our own Milky Way. It is crucial to comprehend these early stages because they lay the groundwork for a galaxy's future by perhaps altering its structure and affecting the birth of stars. Supernova activity and star formation. Massive clouds of gas and dust are compressed by the gravitational pull of galaxies as they collide, thus igniting the formation of new stars. This contact has produced a high star formation rate in IC 2163 and NGC 2207, which is significantly higher than what we see in solitary galaxies. Every year, about 24 stars the size of our Sun are produced by these two galaxies. In comparison, only 2 to 3 stars emerge per year in the Milky Way. The Hubble and Webb photos provide a visual representation of this boom in star creation. Clusters of young, blazing stars can be seen in the vivid blue areas that Hubble photographed in ultraviolet light. The surrounding clouds of gas and dust are illuminated by the dazzling radiance of newborn stars in these cosmic nurseries. Another layer of star formation is revealed by Webb's mid-infrared imaging, which shows the dusty areas where stars are forming but are still obscured, giving them a pink and white appearance. These regions show the locations of future stars that are concealed and awaiting their emergence from the cosmic dust. Because gas may condense more easily in these dusty conditions due to the lower temperatures, they are perfect for star formation. The destiny of both galaxies has been shaped by the contact between IC 2163 and NGC 2207, which has produced favorable conditions for young stars. In this process, supernovae also have a significant impact. In contrast to the Milky Way, which only undergoes a supernova around once every 50 years, these galaxies have had 7 known supernova occurrences in recent decades. A star explosion known as a supernova releases elements such as carbon, iron, and oxygen into the cosmos. By enriching the interstellar medium, these components foster the development of new stars and planets. Supernovae serve as cosmic gardeners, removing space in the galaxy's arms to make room for new stars and starting a massive cycle of life and death. Perspectives from the observations of Webb and Hubble. Fascinating similarities and insights can be found when comparing the findings of IC 2163 and NGC 2207 with research on other galaxy pairs, such as the Whirlpool Galaxy and the Antennae Galaxies. These well-researched galaxies provide insight into the potential future of our recently discovered galaxies and demonstrate the transforming power of galactic encounters. In a far more advanced level of interaction are the Antennae Galaxies, so called because of their characteristic long tidal tails that resemble bug antennae. The centers of these galaxies have started to merge as a result of collisions and matter exchange, resulting in a profound entanglement of gas and stars. As a result of gravitational forces compressing gas and dust clouds to extremely high densities, this pair shows some of the most intense starburst activity ever seen, resulting in areas of fast star formation. Another interesting case study is the Whirlpool Galaxy, M51, and its tiny partner NGC 5195. With distinct arms, M51 is a grand design spiral galaxy that is situated in the constellation Canes Venatici. Its spiral structure has been visibly distorted by its interaction with NGC 5195, with one arm extending towards its smaller neighbor and forming a bridge of material with star formation areas. New star formation is thriving on this gas and dust-rich tidal bridge. Additionally, the interaction has resulted in an extended gas and dust envelope surrounding M51, underscoring the influence of gravity. The spiral arms of the whirlpool have formed complex patterns that demonstrate how gravitational interactions can change the internal structure of a galaxy. Compared to what we now see with IC 2163 and NGC 2207, this scenario offers a more mature and detailed image of galactic interaction, but it also offers a glimpse of what can happen in the future as their gravitational impacts become more intense. Interstellar travel and the universe's future. Astronomers can investigate the mechanisms that shape the universe in a dynamic laboratory thanks to galactic interactions like these. By looking at IC 2163 and NGC 2207, we can see signs of the future life cycle of galaxies in addition to the star formation process. These interactions imply that galactic mergers, which change galaxies' forms, cause starbursts, and occasionally even ignite black hole activity at their centers, are essential to the evolution of galaxies. We might someday learn more about the future of our own galaxy from the data obtained from these encounters. The final collision between the Milky Way and Andromeda will change the shape of both galaxies, causing star formation and perhaps even changing the appearance of the combined galaxy to something completely different. Conclusion: the value of observing the cosmos. We get closer to comprehending our role in the enormous fabric of space with each new discovery like this one. Every picture taken by telescopes such as Webb and Hubble offers a window into the dynamic and constantly changing character of the cosmos. We are reminded of the strength of gravitational interactions and the enduring beauty of the cosmos by these two galaxies, which are locked in a beautiful yet furious dance. We appreciate you traveling with us into the cosmos. Stay curious and keep looking up till the next time.